Hey, let's finish up with inverse trig function derivative homework 61 and 63. 61 says find the equation of a tangent line to a graph. So in order to find the equation of a tangent line, we need two pieces of information. We need to find the slope and the ordered pair. So we have the ordered pair here, 1/2 pi over 3. The only thing we need to really find is the slope, and once we have that, we can plug into our point slope form for our line. So 2 times arc sine of x. I'm going to first find the derivative using the implicit rule. So first we got to get the arc sine by itself, so we can take the sine of both sides, so divide both sides by 2, take the sine of both sides. So sine of arc sine of x is simply going to be x. So now we can find the derivative. So sine of u becomes cosine of u times u prime, so the derivative of y over 2 is simply 1/2 times dy dx. X turns to 1. Okay. To solve for dy dx, we divide both sides by cosine of y over 2, so 2 over cosine of y over 2, and we're going to take steps now to replace y in terms of x. So y over 2, if we look at the second step here, is the same thing as arc sine of x. So I can write it as 2 over cosine of arc sine of x, and want to find out cosine of the angle when sine is equal to x. So sine is equal to x, with x being the opposite, 1 being the hypotenuse, Pythagorean theorem to get to the third side, square root of 1 minus x squared. So cosine of theta is simply going to be square root of 1 minus x squared over 1, so 2 over square root of 1 minus x squared, and that's going to be our derivative. Okay. Once we have our derivative, again, you can also use the derivative rule for arc sine of x to get to this point here. Okay. Now, once we find the derivative, we got to use this to find the slope. So we're going to plug the x value into the derivative to find the steepness at this point. So plug 1/2 in for x. Do with some fractions here. So 2 over square root of 1 minus 1/4. I want to combine this together. So find a common denominator being 4. So 4 over 4 minus 1/4 is square root of 3 over 4. Square root of 3 over 4 is something like square root of 3 over 2. And then flip it to move the 2 up to the top, so 4 over root 3, so that's my slope. So I have my slope, I have my ordered pair, and I plug into point slope. Okay, y minus y pi over 3 is equal to m times x minus x of 1, 1/2. Okay, 63. Again, we want to find the equation of tangent line to our function, our tangent of x over 2 at 2 pi over 4. First off, we want to find the derivative, and then we can, from there, find the slope. Take the tangent of both sides, so we're left with tangent of y is equal to x over 2. Derivative of tangent of y is secant squared y dy dx. 1/2 x becomes 1/2. To solve for dy dx, we divide both sides by secant squared of y. I'm going to just move the secant squared y to the top and think in terms of cosine. Okay, so cosine squared of y, replace y in terms of original equation. We're trying to work our way to be in terms of x. So arctangent of x over 2. So x over 2, tangent of theta is equal to x over 2, with x being the opposite, 2 being the adjacent. So Pythagorean theorem, we can find hypotenuse being square root of x squared plus 4. So cosine of theta is simply going to be 2 over square root of x squared plus 4. But remember, this cosine square, so we got to take, we got to square this ratio here, times 1/2. I'm just bringing this 2 out to a different fraction here. Okay, so I can isolate these two different steps here. I'm going to square my fraction here, so 4 over x squared plus 4 times 1/2. The 2 and 4 cancels out, leaving us with 2 over x squared plus 4. So all this step is just to get to the derivative. Once we have our derivative, then we can find the slope. At that x value of 2, so plug 2 in for x, we get 2 over 4 plus 4, 2 over 8, which is 1/4, so that's my slope. So plug into point slope, y minus pi over 4 is equal to m, my slope, 1/4 times x minus 2.